don't have much time. Is the presentation working? Is it a clicker or something or not? If not, anyway, we have just 5 minutes or something before the panel. I don't know how much you know about SandboxAQ, so let me tell you the story and we'll take it from there. SandboxAQ actually originated in Google X, the moonshot factory in 2016, if you're familiar with it. The reason that it started, the founder was asked by Sergey Brin to figure out quantum, not the hardware side, but the software side for the company. In 2021, we spun out of Alphabet. It was the first and only ever clean spin out of Alphabet, meaning Alphabet didn't maintain a single part of the equity. And we focus now on AI and quantum. That's where A and Q come in terms of Sandbox. And what does that actually mean? So there are 4 key divisions in the Sandbox, but here we go. We can start. So I'm going to go through this quite quick. So I'm going to let you know when to move through the slide. Just to give you a view of our thought in terms of AI. There is a clicker. Here we go. Okay, let's quickly go through this. So again, we are now in the intelligence revolution, which some people consider to be the last human invention. The reason that they consider that the last human invention is they believe that any future inventions would be done by the AI as well as they close the loop. That's the rapid, recursive self-improvement that everybody in a way is anticipating on the one hand and terrified on the other. Now the continuum, looking at it from a Google perspective, I've been at Google 12 years, so this is the approach that people are looking at. Everybody is looking towards or walking towards or running towards the holy grail of artificial intelligence, which is artificial super intelligence, or AGI on the other hand. But during that process, there was a break, and that break was actually large language model. It was a necessary step towards AGI, but it actually skewed the focus of a lot of the industry in terms of where we were going. Now, the way that I thought of explaining it is using this example. You don't have the voice. I don't know if we can have it. But if anybody remembers Back to the Future, that's when everything sort of skewed in terms of the timeline. So if we take that analogy and use it for AI, so AI went on the same continuum toward AGI, but it skewed in a way too heavily towards LLM. Because if you ask if the majority of people what is AI and LLM, they use those terms interchangeably. But LLM can't solve all problems, and that's what we're going to discuss in terms of what Sandbox really does. And there are voices that have started talking about it, some godfathers of AI, Yann LeCun is one of them, that LLM are fantastic, they create a lot of value, but they are not the path towards AI. We need a new architecture or multimodal approach, not multimodal, in order to reach that level. And there are other people across the industries. We have Dr. Fei-Fei Li, the godmother of AI, who started her own startup and be developing what's called world models. We have Jack Hidary, our own sort of founder and CEO, focusing on LQMs, large quantitative models, which we believe depict the real way the world works, how nature actually works, not words, but actually numbers. And you've got sort of Ilya Sutskever as well, looking right now to the age of discovery, moving away from scale into discovery. And actually, Demis Hassabis from Google DeepMind and Google overall were very much on the approach of scaling. We can reach AGI through scaling, and he's now having a change of mind a little bit, and he's looking into more of a hybrid model, understanding that we need new models, not just LLM architecture, in order to develop those capabilities that as humans we have. So to summarize, there are 2 traditional thoughts that now are more moving towards a new architectural innovation of AI. The scaling hypothesis, which in a way makes sense, using billions and trillions of tokens, more compute, more energy, more storage. And that actually it's how the brain works. Any decision that we make involves billions and billions of neurons and synapses that connect to one another. But on the other hand, there's the approach of a new architecture, because the way we operate as humans, we have multiple systems that each one in a way do an API call every time we need it, from spatial intelligence and so on and so forth. So the idea of all of this is, if we think about LLM, the other problem with it right now is the focus has pretty much been on what can we gain out of LLM in terms of efficiency. What we're saying is LQM, which is more physical reality, can create new industries, new segments, and as a way, new jobs. And that's where we see how we can go away from the zero-sum game. Because right now, if the majority of the work or the benefit of LLMs is reducing jobs or reducing industries, then only a selected few, an exclusive group of people are going to be billionaires and millionaires, and the rest of us are going to be jobless. And we see some indications of that when just ChatGPT launched in terms, I mean, the correlation is so clear, it's almost like a causation. How would this end is a different sort of question that we'll have to wait and see. Now, the next frontier, what we do in Sandbox, is large quantitative models. I'll explain exactly what they are. The idea is, again, more of creation, new paradigms, as opposed to just efficiency and remove stuff off someone's plate, making it more efficient. Now, why is that a much bigger opportunity in industry? Let's look at 6 industries that are very much quantitative based. Some of them are financial, some of them from the nature, and so on and so forth. If we look at LLM, they are relevant to all of those industries. But in terms of the impact of what they can do, the efficiency, get you emails and documents, whatnot, it's limited. If we put LQM, we're talking about completely different dynamic, much more opportunities to create not just novel drugs and stuff like that in biology, but a completely new science, and we can talk about that if we have time afterwards. So to summarize, on the one side, LLM right now, it may change, is very much a cost-cutting tool, where LQM is the opposite. It's a value creation engine, new revenue streams, new opportunities, new science, which is, again, based on the core basic unit of how the universe works, which is quantitative, not words. Let's look at a quick video of what we do.
Today's AI hits a semantic dead end in high-value science. LLMs excel at reasoning, but lack the rigorous tools to physically validate molecules or analyze proprietary data. The solution is a hybrid model system. We position SandboxAQ's Large Quantitative Models, or LQMs, as the rigorous computational engine for your model's flexible reasoning. We're already delivering this at industrial scale, running drug discovery for major pharma and sovereign nations. Together, we can unlock 3 revenue horizons: making scientific data searchable via natural language, deploying agentic co-scientists, and using our simulation data to fine-tune your foundation models. And it's a seamless handoff. The foundation model acts as the project lead, asking our LQMs to do the heavy math. The answer isn't just a guess. It's backed by the laws of physics. Our agents have already identified novel drug candidates that target obesity, which are ready for synthesis. Let's integrate our LQM capabilities into your AI platform and capture the high-value workflows you're missing today.
And we're already doing that with a few both frontier models as well as customers. And just I'll summarize with this. When we think about the natural sciences of the world, biology, chemistry, physics, and so on, these are in a way also human constructs. Nature works holistically across all of them. It doesn't know when chemistry starts and biology ends. And AI is allowing us, or giving us in a way the key or the tool, not just to explore how the intersection between those sciences, which is many times where the innovation comes from, but also potentially explore and accelerate new sciences that we're not aware of. Quantum is definitely one of them. The key strategic framework, and with that I will end, is again focusing on discovery as opposed to just efficiency of the current way, and resist as much as possible, which is difficult in a capitalist system, short-termism, because it requires a longer view. And again, augment humanity as opposed to replace it, creating new types of roles like simulation directors and so on and so forth. I think that's it. Thank you very much.
Thank you. While I introduce the next panel, can you please ask them to come? It's your panel, right? No. Can you please ask the panelists to come back here, because I know that they are still working on the questions. Where is... No, not yet. They're coming. All right. So the next panel we have, you all as a panelist, you stay. And Liz Perkins will be the moderator. Then we have Kali Kavnes, Sandra Triton, and Giro AI. I'm looking forward to see the panelists. And in the meantime, do you have questions about the keynote or to our speaker? No questions? You have. All right.
My question is, as I understood correctly, so you want to build something like AGI, but for particular sector, right?
No. So the AGI is where the industry is going. We contribute the scientific quantitative part. So if you ask, we did a test with Claude, for example. We asked it physics questions. It gave an answer very confidently with words. The answer was wrong. Then we connected it to the LQM. It gave a different answer. The answer was right. That's what we provide. We provide sort of the physical heavy lifting to ensure that the LLM provides you the correct information, which is based on maths as opposed to words, which currently it can.
It's like a world model, right? You build something.
You can call it that. There's another approach. There's a constellation approach, which requires multiple models that check each other's models, different types of model. It's almost like a narrow AI within AI. Different types of models to ensure that we capture the entire sort of spectrum of information.
And we're solving problem is a long memory also?
That's part of it, but that's more in terms of the latency of it and other issues, not necessarily the content of it.
Thank you. All right. Thank you. Okay, I see. You have a question already. One more question while the panelists are coming up. All right.
So thank you. I work in the physical AI informed AI, physics informed AI, so very much like LQM. So I was listening to the DeepMind from Google last night about quantum computing. Do you think the LQM need the support from quantum computing, or the current computing architecture can support that? Because you talk about biology, everything, the traditional computing system has a lot of limitation on that.
So in terms of quantum, we need to separate between quantum technology and quantum computing. Quantum computers may come, but there's some time for that. But in terms of leveraging quantum sensing, the subatomic level, we can do that already today. With the help of AI to reduce the noise, increase the volume, the signal, we can actually apply it, and we do in several sort of areas. Also, not using a quantum computer or chips, but using sort of GPUs as well, classical computers. So it is possible, and actually AI, I think, would accelerate quantum as well.
Thank you.